Hello my dear students, hope you all are fine, and we are in continuation with the chapter motion in a plane. In the last class we have studied about the projectile motion in brief, and we have solved all the mathematical equations related to that, and we have solved one or two questions, and now we are going to study about the relative velocity. You might be wondering that we have already studied the relative velocity in earlier chapter, but in this relative velocity we will be studying in the two dimensional motion. In the previous chapter it was in one dimensional, that is in rectilinear motion. Now we will be studying the relative velocity in respect to the two dimension. That is relative velocity. We know that the velocity of an object with relation to other, that is simply relative velocity is the velocity of an object with relation to the other object. Now let us consider a car and a bike. Both are in same direction. When both are in same direction, what will be the relative velocity? That means relative velocity of car with respect to bike, or simply velocity of car with respect to bike. So velocity of car in relation to bike, that we can write Vc is equal to, let us take this is Vc and this is Vb. Vc is equal to, both are in same direction, car with the velocity of Vc, bike with the velocity of Vb. Velocity of car in relation to bike is, as we have seen earlier, Vc minus Vb. Vc minus Vb. This let us take it as a first case, and in the second case, when the car and bike are moving in the opposite direction, say this is Vc and Vb, what will be the net velocity, or we can say velocity of car in relation to bike, that is Vc equal to Vc plus Vb, that is Vc vector plus Vb vector. From these two we can conclude that when both the objects are moving along the same direction, then the relative velocity is Vc minus Vb. When both are in opposite direction, the velocities are added, that is velocity of car in relation to bike, that is Vc is equal to Vc plus Vb. Alternatively, velocity of bike in relation to car can be written as Vb equal to Vc plus Vb. In this condition, what we find that the relative velocity of car with respect to bike and the relative velocity of bike with respect to car both are same. So we can write Vc is equal to Vb, that is relative velocity is same. Now let us do one numerical to understand the concept nicely. Let us proceed with the problem. The velocities v1 and v2 of two objects are given by vectors v1 is equal to 3I plus 4j minus 4k, and V2 is equal to 2I minus 3j minus 4k, where I, j and k are unit vectors. Find the relative velocity of the first object with respect to the second, and what can you say about this vector? This is what the question given. Now we can note down that two objects are there and having velocities v1 and v2. So v1 is given, that is 3I plus 4j minus 4k, and v2 is equal to 2I minus 3j minus 4k. What is to be found here? Velocity of first object with respect to the second. So v of 1 2, velocity of object 1 with respect to the object 2. So we know that v12 is equal to v1 minus v2. It is a simple vector subtraction. So we can write here v1 is 3I plus 4j minus 4k, that is v1, minus v2 is 2I minus 3j minus 4k. Now we can subtract it separately, I, j, k terms. So we can write 3 minus 2 I cap plus 4 minus of minus plus 3 j cap plus minus 4 minus of minus, this will become plus 4 k turn. From here we can get that this minus 4 and plus 4 will get cancelled. So we can write 3 minus 2 1, that is I cap plus 4 plus 3 7j, and this becomes 0. So velocity of object 1 with respect to object 2 is I plus 7j cap. Next is, what can you say about this vector? From this vector we can get that I term is there, j term is there, there is no k term. So we can say that it is moving along the path of xy plane. It is moving along the path of xy plane. So it was a simple question to understand the relative velocity. We shall go for it. There are numerous problems in this topic, relative velocity, and some of the questions are regularly or frequently asked and which are considered to be very important, and we shall discuss the some of important terms and related formulas in three types only. One is boat, river, / swimmer problem, that is question related to the boat moving in a river or a swimmer in a river crossing along or opposite direction and in the same direction, we shall discuss. And next one is rain umbrella problem. Rain umbrella problem means raining in one direction, and at what direction we need to place the umbrella. Such type of questions were also asked frequently. And next one is aeroplane wind problem. Aeroplane moving in this direction and wind is in opposite direction, then what direction will be the net direction of the aeroplane? These are the three types of questions which were regularly and frequently asked in the question papers. So we will be discussing it separately. So the first one is boat river problem. Boat river problem. Let us consider this is the direction of the river, direction of the river flow. Say the velocity of the river is Vr. Velocity of the river is Vr. If the boat is also moving along this, along the direction, so it may be taken as case 1. when the boat is moving along the direction of the river, say the velocity of the boat is Vb, then what will be the velocity of boat with respect to the velocity of the river? In this case, both are moving in the same direction. So, the flow of the water or river enhances the rate of velocity of the boat also. So, obviously, Vb, velocity of boat with respect to velocity of a river, and both are moving in the same direction. So, we can have Vb plus Vr. That means both are added. In this situation, you should not confuse with the earlier cases what we have seen. When both are moving in the same direction, we are subtracting. Why? Because both are in a separate isolated objects. Let us take example of the last case, that is bike and the car. Bike is separate and the car is separate. That is, the velocity of the bike is not hindered by the car, and the velocity of the car is not hindered by the bike. In this case, the velocity of the river enhances the velocity of the boat. So, here in this case, velocity of boat is equal to velocity of boat plus velocity of the river. Let us take the another case, case 2. When the direction of the river is as such and the boat is moving in opposite direction, that is, river in this direction and the velocity of the boat is in this direction, that is opposite direction. Then what will be the, obviously if the boat is moving against the direction of the river, then it is having the velocity greater than the velocity of the river. So, Vb is equal to Vb minus Vr. Vb minus Vr. These are the two cases we have. Let us consider one more case, that is case 3. Again, the direction of the river flow is in this direction, Vr, and the boat is placed here and supposed to cross the river, that is perpendicular to the direction of the river. Obviously, due to the flow of the river, it will have the tendency to move in this direction. So, that will impact the velocity of the boat also. So, if you draw like this, we will be having a right triangle. So, what will be the resultant vector here? This is Vr and this is Vb. So, this will be the resultant. This will be the resultant vector. So, Vb resultant vector is equal to root over Vb square plus Vr square. This is the Vb square plus Vr square. Now, we can calculate the angle also. Tan theta is equal to, that is Vb by Vr. So, theta is equal to tan inverse Vb by Vr. So, this angle will give how much angle the boat is deviated from its path with respect to the direction of the river. Next is the rain umbrella problem. Let us take that rain is raining downward, that is north to south, and a man is walking from east to west, say Vm, and the velocity of the rain is downward with velocity Vr. Obviously, it will make an resultant vector here, that is the direction of the rain making an angle theta with respect to the velocity of the rain, that is the direction of the rain. Obviously, we have to hold the umbrella in opposite direction. So, this will be the direction of umbrella to be hold. So, umbrella should be here. So, we can have like this. This is the direction of the rain. We have to hold the umbrella like this. If we hold the umbrella like this, this will be the direction of the rain and this will be the direction of the umbrella, making an angle theta with the motion of the man or velocity of the man. So, it can be written theta, that is tan theta, is equal to, that is perpendicular, that is VR by Vm. So, theta can be written tan inverse of VR by Vm. This is the brief about the types of relative velocity problems in plane. Let us do one numerical to understand the concept much deeper. Now, let us take this question. Rain is falling vertically with a speed of 35 meter per second. A woman rides a bicycle with a speed of 12 meter per second in east to west direction. What is the direction in which she should hold her umbrella? So, what is given here? The velocity of rain is given, Vr is equal to 35 meter per second, and a woman rides a bicycle with a speed of 12 meter per second. So, we can take V of B, velocity of bicycle is 12 meter per second. Now, we can have the vector diagram as such. This is the direction of the velocity of rain, that is downward, north to south. Then the direction of the bicycle is from east to west. So, this is the direction of the rain and this is the direction of the bicycle. Then where will be the resultant vector? Obviously, the resultant vector will be here. So, that shows the direction of the rain. Opposite to that, if we extend that, this will be the direction we have to hold the umbrella, making an angle theta with the direction of east. So, this is the direction of the rain and we have to hold the umbrella, making an angle theta with the horizontal, that is east to west direction. Now, we need to find the resultant vector, that is the direction of the rain or the magnitude of the resultant vector. So, we can have R is equal to root over, we know the formula, that is Vb square plus Vr square, that is Vb square, that is given 12 meter per second. So, we can write 12 square plus Vr square is 35 square, that comes to be 37 meter per second, that is 37 meter per second. Where will be the angle at which the rain is falling? So, we can calculate tan theta is equal to 12 by 35, that is Vb by Vr. So, Vb by Vr. So, tan inverse Vb is 12 by 35 or tan inverse theta is equal to tan inverse 12 by 35. So, the value of tan inverse 12 by 35 comes to be 19 degree. So, 19 degree, theta is 19 degree with respect to east, with respect to east direction. So, we have calculated the resultant as well as the direction of the umbrella to be hold or placed. So, this is the direction of the train and this is the direction in which we have to hold the women have to hold the umbrella. When an object is moving in the straight line, when an object is moving in a straight line, we studied that is rectilinear motion. Rectilinear motion. Consider an object is moving in a circular path, then that is a circular motion. How we can define it? Whenever an object is moving in a circular path with uniform speed, then the motion is called circular motion. So, uniform means the object is moving with the uniform speed, that is why it is called uniform circular motion. Let us take an example here. This is a circular path having say radius r. A car is moving along this direction, So, we know that if we draw a tangent to this and join the line to the center, it is making 90 degree. Okay. So, any object which is moving in the circular path with a uniform speed is called uniform circular motion. We know that the tangent gives the direction of velocity. So, this is the direction of the velocity. What about the acceleration? We know that it is changing its position at every point of time, say here, 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 anywhere. If you draw the tangent, we find that every time, every instant of time, it is continuously changing its position and accordingly the direction also. So, it is making a velocity because the direction is changing at every second. So, this is the direction of the velocity. Then what will be the direction of the acceleration? Acceleration is always perpendicular to the velocity of the object. So, this is the direction of the acceleration. So, it is always directing towards the center of the circular path. So, that is why it is called centripetal acceleration. That is called centripetal acceleration. Centripetal acceleration, it is denoted by AC, and the term was given by Sir Isaac Newton. Okay. As in the rectilinear motion, we have calculated displacement, speed, velocity, relative velocity and acceleration also. Similarly, in the uniform circular motion also, we can calculate the displacement, velocity and find the centripetal acceleration also. We shall go for it now. First term is angular displacement. Why it is called angular displacement? When a car is rotating, there is a change in the angle with respect to the center. That is why it is called angular displacement. Let us consider that a car is here initially, say point P1 and making displacement from here to here at point P2. Joining this, obviously making an angle, say del theta with the center. Okay. So, del s can be taken as the displacement, r is the radius. So, what is the angular displacement? Angle subtended by the object from initial point to the final point is called the angular displacement. Then what is that is given by del theta. Moreover, we can write del s is equal to r del theta, r del theta. Next is angular velocity. angular velocity denoted by omega. We know that what is velocity? Velocity is the rate of displacement, rate of displacement. So, we can write omega is equal to del theta by del t, del theta by del t, where del theta is the angular displacement, del t is the time. Okay. Further, from the rectilinear motion we know that velocity is equal to del s by del t, that is displacement by time in the rectilinear motion. From this we know that del s is equal to r del theta. We can put here that is r del theta by del t. So, we can write V is equal to, that is del theta by del t is equal to omega. So, V is equal to omega r, V is equal to omega r. This is the velocity in rectilinear motion, this is the angular velocity. So, the relation which relates the angular velocity and the linear velocity, that is V is equal to omega r. Next term is centripetal acceleration. Centripetal acceleration is rate of angular velocity, rate of angular velocity. We know centripetal acceleration is equal to v square by r. So, AC is equal to v square by r. Just now we have derived that v is equal to omega r. So, we can put here omega square r square by r. So, this will get cancelled, centripetal acceleration will be omega square r. So, this is the acceleration, that is centripetal acceleration. We shall do some numerical here. The question is, a body of mass 0.4 kg is attached to a string 1.2 meter long and then whirled round horizontally making 120 revolutions per minute. Find angular velocity, linear velocity and acceleration. Here a mass of 0.4 kg is attached to a string of 1.2 meter and it is whirled horizontally having 120 revolutions per minute. What we need to find here is angular velocity, linear velocity and acceleration. That is, the radius is given r is equal to 1.2 meter and the revolution is 120 revolutions per minute is given. Say the first one, A, omega is equal to how many revolutions? 120 revolutions, that is 120 by revolutions per 1 minute, 120 by 1 minute. One revolution is equal to 2 pi. We have to convert into radian. So, 1 revolution is equal to 2 pi. So, what will be the total revolution? That is 120 into 2 pi divided by 1 minute is equal to 60 seconds. So, 60. So, 2, 1. So, omega is equal to 2 to the 4 pi, 4 pi rad, that is radian per second. So, omega we have calculated. The second one is linear velocity. Linear velocity we know v is equal to omega r. Omega we have already calculated, that is 4 pi into r is given, that is 1.2, that is 1.2 meter, that comes to be 4 into 1.2, that is 4.8 pi, 4.8 pi velocity meter per second. The third one is acceleration is equal to centripetal acceleration is equal to, just now we have derived the formula omega square r, that is omega square r. Just omega, what is the value of omega? That is 4 pi square into r is 1.2. The result comes to be 189.5 meter per second square, since it is acceleration. So, we have calculated centripetal acceleration, that is velocity we have calculated, that is 4.8 pi meter per second, and angular velocity is 4 pi rads per second. This is how we can solve the questions. So, collectively today we have seen concept of relative velocity with respect to the 2D plane, and we have solved one numerical, and we have discussed the types of questions which are being asked on the basis of relative velocities, that is boat, river question, and rain and umbrella, and we have done one numerical, and we have briefly discussed about the uniform circular motion, that is displacement, angular velocity, and centripetal acceleration, and finally we have done one numerical also. Hope you all understood today's class, and we shall continue in the next class. Thank you.